let's see the problems on Laplace transforms using some of the standard functions. First problem, find Laplace transform of sine of omega t plus alpha. So here we should have the variable only t, and here alpha and omega are the constants. So by using the formula sine of a plus b, that is sine a cos b plus cos a sine b. So here a nothing but omega t and b nothing but alpha. So by using this formula we can write Laplace transform of sine a nothing but sine omega t, cos b nothing but cos alpha, plus cos a, that is cos omega t, into sine b nothing but that is sine alpha. So we get Laplace transform of sine omega t cos alpha plus cos omega t sine alpha. Now we have to find the Laplace transform of this. So I said you that omega and alpha are the constants. So cos alpha is also a constant. So it can be written outside of the transform. That is cos alpha Laplace transform of sine omega t, plus here alpha is a constant and sine alpha is also constant. So we get sine alpha Laplace transform of cos omega t. Now cos alpha into Laplace transform of sine omega t, nothing but sine Laplace transform of sine a t. We know that it is a by s square plus a square. Here a is a constant. Here omega and alpha are the constants. So here a nothing but omega. So that is cos alpha of omega by s square plus omega square plus sine alpha into Laplace transform of cos omega t. So Laplace transform of cos a t nothing but sine s by s square plus a square. That is s by s square plus omega square. So that equals to, from this both the terms we can take 1 by s square plus omega r square common. And the remaining are omega cos alpha plus s sine alpha. So this is the transform of the given equation. And then second problem is also the same. Find Laplace transform of cos of omega t plus alpha. So here the same form, we have to use the formula for cos of a plus b, and we have to simplify it. Then third problem, find Laplace transform of sine 2t cos 3t. So we have the formula 2 sine a cos b is equals to sine of a plus b plus sine of a minus b. So for these terms, we have the constant, so we have written outside, but we have the variable for two of the functions, that is t. So when it is separated by a plus term, we can simplify by using this formula. But here the two functions and which has the two variables, that is t. So we have to use a formula, and when we use this formula the terms get separated here. So here a nothing but 2t and b nothing but 3t. So here a is equals to 2t and b is equals to 3t. So 2 sine a cos b formula, sine of a plus b plus sine of a minus b. So Laplace transform of sine 2t cos 3t can be written as 1 by 2 Laplace transform of 2 into sine 2t cos 3t. So here we are multiplying and dividing with 2. So 1 by 2 into 2 nothing but we get again 1, and it comes back to the same. So we are multiplying and dividing with 2. So now 1 by 2 is a constant, and Laplace transform of, here we can apply 2 sine a cos b. I said you a is 2t and b is 3t. So sine of a plus b, nothing but sine of 2t plus 3t, plus sine of a minus b, that is 2t minus 3t. And then here 1 by 2 Laplace transform of sine of 2t plus 3t is 5t, plus sine of 2t minus 3t is minus t. Then we get 1 by 2 Laplace transform of sine phi t minus sine t. It is not like that this minus is multiplying with plus sign, it becomes minus. It's not like this, but we have the formula here. So when cos of minus theta is cos theta, and sine inverse of minus theta is sine theta, but whereas sine of minus theta is minus sine theta. So by using this formula, sine of minus t can be written as minus sine t. So 1 by 2 Laplace transform of sine phi t minus sine t. Now we can apply the Laplace transform to each of the term separately. So that is here 1 by 2 Laplace is common for both of the terms. So Laplace transform of sin phi t minus Laplace transform of sin t. So 1 by 2 sin a t. Laplace transform of sin a t is equals to a by s square plus a square. So 5 by s square plus y square. Here a is 5 minus sin t, that is 1 by s square plus 1 square. Here a value is 1. Now 1 by 2 of 5 by s square plus 5 square is 25 minus 1 by s square plus 1 is the transformation of the given equation. Find Laplace transform of cos 3t into sin phi t. So here also the same two functions are multiplying with the same variable. So to cos a sin b formula we can apply. That formula comes as sin of a plus b minus sin of a minus b. So Laplace transform of cos 3t sin phi t, that equals to 1 by 2 Laplace transform of 2 into cos 3t sin phi t. So to get this formula we are multiplying and dividing with 2. And here 1 by 2 Laplace transform of sin a plus b. Here a nothing but 3t and b nothing but phi t. A plus b 3t plus phi t minus sin of a minus b, that is 3t minus phi t. So 1 by 2 Laplace transform of sin phi plus 3 phi t plus 3t, that is 8t, minus sin of 3t minus phi t is minus 2t. Then that equals to 1 by 2 Laplace transform of sin 8t, and here a sin of minus theta, that is minus sin theta. Sin of minus theta is minus sin theta. So that minus multiplies with this plus. It multiplies with this minus. Then we get plus sin 2t. So 1 by 2 is common for the both of the terms, and we write the Laplace transform to each of the terms separately. So that is Laplace transform of sin 8t plus Laplace transform of sin 2t. And this 1 by 2 is common to the each of the transforms. Now we have to use a formula. 1 by 2 of sin 8t, that is a formula. Laplace transform of sin 8t is a by s square plus a square. So 8 by s square plus h square plus here also the same formula we have to apply. We get 2 by s square plus 2 square. So here a is 2 and here a is 8. That equals to 1 by 2 of 8 by s square plus h square is 64 plus 2 by s square plus 4. So this is a final answer for the given question. So here is a different type of question. Find Laplace transform of f of t is defined as f of t is equals to e power t when 0 less than t less than 5 and 3 when t is greater than 5. So here in the first case t is lying in between 0 to 5. Nothing but here is 0 in between 0 to 5, somewhere the t is lying. And here t greater than 5, nothing but it lies somewhere, and infinity, because it's a positive infinity, and t is greater than 5. So here a Laplace transform of f of t, we know the formula, that is integration of 0 to infinity e power minus s into t into the function f of t into dt. So here f of t, first time we have to take e power t, and in second time we have to take the 3. So here the integration is from 0 to infinity. So this can be written as integration from 0 to 5. From 0 to 5 e power minus s into t into f of t, we have to take it as e power t into dt, because the integration is from 0 to 5. Because the t is lying in between 0 to 5 and the function f of t is e power t, plus integration from t greater than 5, nothing but 5 to infinity. So that is e power minus s into t into f of t, we have to take it as 3, because t is greater than 5, nothing but 5 to infinity into dt. So this whole integration can be written in these two terms. Then this is a Laplace transform of f of t. Now we have to simplify this. Integration of 0 to 5 e power minus s into t plus t. So here bases are same and they are multiplying each other. So the powers will be added here. Minus st plus t into dt plus 3 is a constant, so it can be written outside. So 3 into integration from phi to infinity e power minus s into t into dt. That equals to integration of 0 to phi e power. So from these both terms we can take common t. So t into 1 minus s into dt plus 3 into integration from phi to infinity e power minus s t into dt. So here we have the formula, that is integration of e power ax into dx is equals to e power ax by a. So here a nothing but constant and x is a variable here. We are integrating with respect to x. So the same formula we have to use here. A is a constant. So in this we have seen s is a constant and t is a variable. So here 1 minus s is a constant and t is a variable. If you compare with this equation, here a is 1 minus s and x is t. So e power 1 minus s into t divided by a, nothing but the constant, that is 1 minus s. So the integration of this is e power t of 1 minus s by 1 minus s. Now the limits are from 0 to 5 plus 3 into e power minus s into t. So in this the constant is minus s. So e power minus s into t by minus s, and integration if we are applying from phi to infinity. So the limits are from phi to infinity. Now we have to apply the upper limit and the lower limit. So while we are applying the limits, first we have to apply the upper limit in a variable t, because we are integrating with respect to t. So in the variable only we have to apply the limits. So first we have to apply the upper limit minus lower limit. So here e power, in the place of t we have to apply the limit. So e power 5 into 1 minus s by 1 minus s. So minus e power 0 into 1 minus s by 1 minus s. So here we have applied the upper limit minus lower limit. So here also the same. Here minus is a constant, so we can take outside of the bracket, that is 3 by minus s, and first we have to apply the upper limit minus lower limit. So e power minus s into t, in the place of t we have to substitute infinity, into infinity minus e power minus s into lower limit is 5. Now we have to simplify this further. So from these both terms 1 minus s is a constant, so take it outside. So 1 by 1 minus s is a common, and e power 5 of 1 minus s, here 0 multiplies with 1 minus s and it becomes 0. So e power 0 value is 1. So that is minus 1 here. Then here plus into minus is minus, 3 by s, e power infinity value is 0 minus e power s into 5, that is minus 5s. Now e power 5 into 1 minus s by 1 minus s plus 3 into minus is plus, and here we get minus 1 also, and then here minus into minus is plus, 3 into e power minus 5 into s by s. So this is the final answer for the given problem. So here is a similar problem. Find the Laplace transform of f of t, defined as f of t is equals to 1 if 0 less than t less than 1, and it is 0 if 1 less than t less than 2, and it is 5 if 2 less than t less than 3, and f of t is 0 if t is greater than 3. So similarly as we did in the previous problem, we have to apply the limits from 0 to 1, 1 to 2 and 2 to 3, and greater than 3 nothing but 3 to infinity. So first we write the formula. Laplace transform of f of t is equals to integration from 0 to infinity e power minus s into t into the function f of t into dt. So this function f, this is constant here. We have to take the same in all the integration part, but f of t changes according to the values of t. So at first t is lying in between 0 and 1, and here it is lying between 1 and 2. And here t is lying in between 2 and 3. Here it is lying somewhere above the 3. It means till infinity. So first it is lying in between 0 to 1, where at the time f of t is 1. So integration from 0 to 1 e power minus s into t. So f of t is 1 into dt, plus when we take the t value from 1 to 2, so integration from 1 to 2 e power minus s into t, f of t value is 0 into dt, plus integration from 2 to 3, at the time f of t value is 5. So e power minus s into t into f of t's value 5 into dt, plus integration from 3 to infinity. T is greater than 3, nothing but 3 to positive infinity, and e power minus s into t. So at the time f of t value is 0. So into 0 of dt. That is equals to integration from 0 to 1 e power minus s into t into 1 is e power minus st dt, plus here it is multiplying with 0, so whole integration part is 0, plus 5 is constant, so write outside of the integration. So 5 integration from 2 to 3 e power minus s into t dt, plus here also the it is 0 is multiplying with this, so whole integration part becomes 0. So plus 0. Now here integration of e power minus s into t. As I told you that s is a constant and t is a variable. So e power minus s into t by minus s by using the formula. And integration, the limits are from 0 to 1. Plus 5 into, here also the same, s is constant and t is a variable. So e power minus t st by minus s. And limits are from 2 to 3. So apply the limits. First we have to apply the upper limit minus lower limit. In the place of t we have to substitute. Since t is a variable and we are integrating with respect to t. So e power minus s into 1 by minus s minus of the upper limit we have to substitute. So lower limit we have to substitute. That is e power minus s into 0 by minus s, plus 5 into, here also the same, we have to apply the upper limit minus lower limit in the place of t. So e power minus s into 3 by minus s minus e power minus s of 2 by minus s. So here e power minus s divided by minus s, and here minus into minus is plus, and e power 0 value is 1. So 1 by s, plus 5 into e power 3 minus 3s by minus s, and minus into minus is plus e power minus 2s by 2. Then e power minus s by minus s plus 1 by s. So multiply this 5 inside the two terms. So we get plus into minus is minus, 5 into e power minus 3s by s, and plus into plus is plus, 5 into e power minus 2s by s. So this is the final answer for this question. Here is the final problem on this topic. Find the Laplace transform of f of t, where f of t is equals to sin t and 0 less than t less than pi, and f of t is 0 when t is greater than pi. So here t is lying in between 0 to pi, and here t is greater than pi, nothing but from pi to infinity. So by the formula, Laplace transform of f of t is equals to integration of from 0 to infinity e power minus s into t f of t is equals into dt. So first integration from 0 to pi e power minus s into t, f of t is sin t in the interval 0 to pi. So e power minus s into t into sin t dt, plus t when f of t is 0 when the in between the interval pi to infinity. So integration from pi to infinity e power minus s into t is f of t is 0 into dt. That equals to integration from 0 to pi e power minus s into t sin t dt, plus this 0 is multiplying with this whole, so whole differentiation integration is 0. Then here there are two functions here. E power minus st is one function and sin t is one function. So we have the formula. integration of e power ax sin bx into dx is equals to e power ax by a square plus b square into a into sin bx minus b into cos bx. So this is the formula we have. When we compare this equation with this question, a value is minus s and b value is 1 here. So here t is a variable and s is minus s is a constant here. So b value is 1 and a value is minus s. So this whole can be written as, by using this formula we can write it as e power ax, nothing but e power minus st divided by a square, that is minus s whole square, plus b square, nothing but 1 into whole square, and into a minus s sin bx is sin t minus b into, so 1 into cos bx, nothing but cos 1 into t, and this after integration we have to apply the limits from 0 to pi. So limits are from 0 to pi, and this limits is for whole the function. Then here e power minus s into t by minus s whole square is s square plus 1 square is 1 into minus s sin t minus cos t, and limits are from 0 to pi. Now apply the limits here, upper limit minus lower limit. First apply the upper limit in the place of t, because t is a variable and we are integrating it with a variable t. So e power minus s into pi by s square plus 1 into minus s sin pi minus cos pi minus, now we have to apply the lower limit in the place of t, e power minus s into 0 by s square plus 1 into minus s sin of 0 minus cos of 0. So e power minus s into pi by s square plus 1 and minus s into sin pi value is 0 minus cos pi value is minus 1 minus e power 0, here minus s into 0 is 0 by s square plus 1 and sin 0 value is also 0. So minus 0 minus cos 0 value is 1. Now we have to simplify this further. S square plus 1 of 0 plus 1 minus 1 by s square plus 1 of minus 1. So here the when we take LCM, 1 by s square plus 1 of e power minus s into pi minus into minus is plus 1. So that is 1 plus e power minus s into pi by s square plus 1 is the final answer for this question.